Hello everyone, my name is Sachin and I will be discussing the mathematics paper of part test 3 in this video. So question 51, f of x is continuous at x equals pi by 2. So the value of f of x at x equals pi by 2. What is the condition for the function to be continuous at x equals pi by 2? The value of the function should be equal to the value of the limit, right? So the function is 1 minus sine x by pi minus 2x whole square. So you can observe that this limit is in the form 0 by 0. So use L'Hopital rule. And I think you'll have to apply it twice, but that will give you the answer, right? So that was question 51. Question 52, limit as x tends to 3, step of x squared minus 9 by x squared minus 9. So here you have a step function and the limit is being asked at an integer value, right? So let's look at this function here. So when x tends to 3 plus, then I can say step of x equals 3, which means f of x will be the same as 0 by x squared minus 9 because step of x tends to 3, right? Now when x tends to 3 minus, step of x will be 2. When x is slightly less than 3, we tend to take step of x as 2, which means f of x will be minus 5 by x squared minus 9. So what does this tell you? It tells you that the right limit at 3 for the given function is 0, whereas the left limit at 3 for this function tends to plus infinity, right? So how do we know it tends to plus infinity? The reason is the numerator is negative and the denominator tends to 0 minus. X is slightly less than 3. So x square minus 9 will tend to 0, but it will be less than 0. So what happens when you divide two negative quantities? You get a positive quantity, and because the denominator tends to 0, the left limit tends to infinity. Anyway, because of all of this, the limit does not exist, right? Because the left limit and the right limit are not equal. Question 52, the point of local maxima of the function. So another simple question here. You just have to figure out where the first derivative is 0 and you have to check whether the second derivative is negative at that point, right? That is the condition. These are the conditions for a function to have a local maximum, right? Question 54, limit x tends to 0, x power a sine x whole power b divided by sine of x power c. So here you have a limit which is of the form 0 by 0. But you can see here that using L'Hopital rule may not be a very convenient method because you have x power c, you have different powers of x here, right? If you contrast that with question 51, using L'Hopital rule twice will give you the answer. If you use L'Hopital rule twice, then the limit, in this limit, the numerator and denominator are both non-zero. But in this particular question, L'Hopital rule may not be a very feasible method. Instead, we try to convert this into a standard limit, right? The most standard limit that we have is that limit as x tends to 0, sine x divided by x tends to 1, right? So in this case, I have limit as x tends to 0, x power a, sine x whole power b, I will multiply and divide by x power b, right? Then this is divided by sine of x power c, I will multiply and divide by x power c, right? So then I will get limit as x tends to 0, x power a plus b minus c, sine x by x whole power b, and in the denominator I have sine of x power c divided by x power c, right? So what do we observe here? As x tends to 0, sine x by x whole power b tends to 1, sine of x power c by x power c also tends to 1. But because the limit must exist and have a non-zero value, the power of x must be 0, right? Otherwise, let us say a plus b minus c is some positive value. Let us say a plus b minus c is 2. Then the limit will tend to 0. And if a plus b minus c is negative, let us say it is -2, then the limit will not be finite, right? So the necessary condition for the limit to exist and to be non-zero is a plus b minus c equals 0. Question 55, f of x is given. You have to find the derivative at 1, derivative at 4, derivative at 5, and then substitute them into this expression. So quite an easy question here. What is f dash x? F dash x is 2mx plus n. So you can just substitute x equals 1, x equals 4, x equals 5, and then calculate this quantity that has been used. Question 56, f of x is given. It's a piecewise function. F of x is continuous at x equals 4 when. So what is the condition for a function to be continuous? The value of the limit must be equal to the value of the function. And here, because you have two different definitions for x less than 4 and x greater than 4, you must find out both the left limit and the right limit, right? Now, as x tends to 4 minus, right? As x tends to 4 minus, it means that x minus 4 is negative, which means f of x is the same as minus 1 plus a, right? Because x tends to 4 minus, modulus of x minus 4 can be written as minus of x minus 4. Whenever x minus 4 is negative, modulus of x minus 4 can be written as minus of x minus 4, right? Similarly, as x tends to 4 plus, f of x is 1 plus b, right? So based on this information, what is the left limit of the function at 4? It is minus 1 plus a. The right limit of the function at 4 is, 1 plus b. And the value of the function at 4 is defined as a plus b. Now, all these three quantities must be equal. So a plus b equals minus 1 plus a, and a plus b equals 1 plus b. So from here, we get the values of both a and b. Question 57. If limit x tends to a, f of x by g of x exists, then, so this is a bit of a theoretical question. So let us say you have a limit of a function, which is of the form f of x by g of x, right? So if this limit exists, is it necessary that the individual limits also exist, right? So let's look at the options here. Both a limit f of x and g of x must exist. F of x need not exist, but g of x must exist. Neither limit f of x nor limit g of x may exist, and limit f of x exists, but limit g of x need not exist. So here, in questions like this, if you want to prove the statement, then you need a proper mathematical proof. But to prove that a statement is false, just one example is sufficient, right? So in this case, the answer is C. It is not necessary that either limit f of x or limit g of x exist as x tends to a, right? So let's take an example of that. So let us say you have limit x tends to 0, 1 by x, right? Limit x tends to 0, 1 by x does not exist. And what is the reason for this? This is because the left limit tends to minus infinity and the right limit tends to plus infinity, right? Similarly, we can say limit x tends to 0, cosecant x does not exist. Limit x tends to 0, cosecant x also does not exist. Again, for the same reasons, the left limit tends to minus infinity, the right limit tends to plus infinity, right? Now let me define 1 by x as f of x and cosecant x is g of x, right? Now what is limit x tends to 0? F of x divided by g of x. It is limit as x tends to 0, sin x by x, a well-known limit which we know as 1, right? So here we have shown with an example that even if f of x and g of x, the limit of f of x and the limit of g of x is not defined at a certain point, the limit of f of x by g of x can be defined at that point, right? So the correct answer is C. Question 58, f of 1 is given, f dash 1 is given, the derivative of f of x. Okay, so here you need to find the derivative of, so y is f of, f of x plus f of x whole square. Now we'll try to find the derivative here. Now when you're finding dy by dx, remember this is a composite function, right? And how do we differentiate a composite function? Let us say you have f of g of x. Then the derivative of f of g of x is f dash of g of x into g dash x, right? Using the same logic, here you have f dash of f of x into f dash of f of x into f dash x. That is the derivative of the first term. For the second term, use the chain rule again. So derivative of f of x whole square is 2 times f of x into f dash of x, right? So derivative of a composite function is something we are familiar with as the chain rule, right? So another way of understanding this is, let us say g of x is u, right? Let us say g of x is u. Then d by dx of f of u can be written as d by du of f of u into du by dx. So when I say f dash of g of x, it means derivative of f of u with respect to u, or derivative of f of g of x with respect to g of x. And the other term, g dash of x, is du by dx. Anyway, so in this question, you need to find dy by dx at x equals 1. So you just need to substitute x equals 1 in this expression. You will get the value of the derivative, right? Question 59, you have a limit x tends to 0, tan of pi by 4 plus x whole power 1 by x, right? So what do you observe here? You have limit x tends to a, f of x or g of x, and this is of the form 1 power infinity, right? So when x tends to a, f of x tends to 1, and g of x is not finite, right? So 1 by x is not finite as x tends to 0. So how do you evaluate the limit of this form? We've discussed this in one of the earlier papers, I think. So this is e power limit as x tends to a, f of x minus 1 times g of x. So I need to apply the same here and evaluate the limit. Question 60, a function is given and this function is continuous at x equals 0. So again, we have the same concept as in the previous question, right? First thing is, for the function to be continuous, f of 0 must be equal to limit as x tends to 0, f of x. Now in this question, f of 0 is given. F of 0 is e power alpha. And this is equal to limit as x tends to 0, cot of x plus pi by 4 whole power 1 by x. Right? Now this is also a limit of the form 1 power infinity. So this I can evaluate by taking e power limit as x tends to 0, cot x plus pi by 4 minus 1 times 1 by x. Right? Now what happens is the limit in this exponent is of the form 0 by 0. Right? So I can use the L'Hopital rule to evaluate this limit. I will get e power limit as x tends to 0. What is the derivative of the numerator? Derivative of cot of x plus pi by 4 is minus cosecant square x plus pi by 4. The denominator here is x, its derivative is 1. Right? So now this limit is not in 0 by 0 form and you can evaluate it. Question 61. A, B, C are unit vectors such that modulus A plus B plus C is 1 and A is perpendicular to B. right? Also, C makes an angle alpha with A bar and an angle beta with B bar. So you have to find cos alpha plus cos beta. Now, when we want to find the cosine of the angle between two vectors, we need to find the dot product, right? Based on the information given here, how do I bring the dot product into the picture? I have modulus of A bar plus B bar plus C bar equals 1, which means even if I square it, I will get 1. Now, if I expand modulus of A plus B plus C whole square, I have mod A square plus mod B square plus mod C square plus 2 times A dot B plus 2 times B dot C plus 2 times C dot A equals 1, right? Now, mod A square is 1, mod B square is 1, mod C square is 1, because A, B, C are unit vectors. A dot B is 0 because A is perpendicular to B, plus 2 times B dot B, B dot C will be 2 times cos alpha plus 2 times cos beta equals 1. So from here, we will get the value of cos alpha plus cos beta. Question 62. The direction cosines of a line satisfy the relations lambda times L plus N equals N and Mn plus Nl plus Ln equals 0. Okay, so the value of lambda for which the two lines are perpendicular to each other. So we're very familiar with this question, I think from class 11. So the direction cosines of the line, two conditions are given. We need to eliminate one of the terms here to get an idea of the question. So I have n equals lambda times L plus M. This I will substitute in Lm plus Mn plus Nl equals 0, right? So that means I will get, so from here I can write Ln to N plus L plus M times N. And in place of N, I will write lambda times L plus M equals 0, right? So if I expand this, I will get lambda times L square plus Ln times 1 plus 2 lambda plus lambda times M square equals 0. Now, one important thing I want to stress here is we are not trying to solve for L or for M. Here, we will divide both sides of the equation by M square, right? So that means lambda times L square by M square plus L by M times 1 plus 2 lambda plus lambda equals 0, right? So the reason we're doing this is now this is a quadratic in terms of L by M. And if we're talking about the direction cosines of two lines, then L1 by M1 and L2 by M2 are the roots of this equation, right? Where L1, M1, N1 are roots of, L1, M1, N1 are direction cosines of the first line, and L2, M2, N2 are direction cosines of the second line. Then L1 by M1 and L2 by M2 are the roots of this particular equation. And from here, I can write the product of the roots L1, L2 by M1, M2. This is lambda divided by lambda, which is 1, right? L1, L2 by M1, M2 is 1. Now we would want to do the same thing with n by n, right? So how do I take this equation and eliminate L? So to do that, so this could get slightly lengthy, but let's look at this particular part. So you have n equals lambda times L plus n, which means L equals n by lambda minus n, right? Now this I will again substitute in the main equation given, right? So that would mean m plus n times L is n by lambda minus m plus mn equals 0, right? Now if I expand this, I will get minus m square plus mn by lambda plus n square by lambda equals 0, right? Now, similar to what we have done in the earlier step, I will divide the whole equation by n square. Then I will get 1 by lambda times n by m whole square plus 1 by lambda times n by m minus 1 equals 0, right? So similarly, n1 by n1 and n2 by n2 are the roots of this equation. So what is their product? n1, n2 upon n1, n2. This will be minus 1 divided by 1 by lambda, that is minus lambda. Right? Now we get to the final part of this question. The reason we are finding L1, L2 by M1, M2 and N1, N2 by M1, N2, right? So if you have the DCs of two perpendicular lines, what is the condition for two lines to be perpendicular? It is L1, L2 plus M1, M2 plus N1, N2 equals 0. Now if I divide M1, M2 across this, I will get L1, L2 by M1, M2 plus 1 plus M1, N2 by M1, M2 equals 0. But what did we just what did we just find out? We found out that L1, L2 by M1, M2 is 1 and N1, N2 by N1, N2 by M1, M2 is minus lambda. That's 0, which means lambda equals 0. Right. So this particular question is slightly lengthy, but I hope you get the gist of it. We are not looking for the angle between the two lines, right? And we have three unknowns and two equations, which is why we've had to take such a route towards writing this condition. The main condition is L1, L2 plus M1, N2 plus M1, N2 is 0. Question 63, limit as x tends to 0. All right, so you have a limit here, which is of the form 0 by 0. But I don't think using L'Hopital rule is recommended here because, you know, you have x tan 4x in the denominator. And the second reason here, I can see most standard limits in this particular question. For example, you have limit as x tends to 0. 1 minus cos 2x can be written as 2 sine square x. And 3 plus cos x, let us leave it as it is, divided by x tan 4x. Now, whenever you spot a very big expression in the numerator and the denominator, do not go for L'Hopital rule because it becomes cumbersome. Again, I'm coming back to question 51. There, using L'Hopital rule twice will give you the answer. Here, it might get tedious, right? So what we do instead here is, in the numerator, I have 2 sine square x. So that means I can multiply and divide by x square because I'm trying to write everything in terms of a standard limit. Then I have 3 plus cos x divided by x times. In the denominator, I have tan 4x. So I will multiply and divide by 4x. Right? Now, if I rewrite this, rearrange the terms in this expression, I have 2 times x square in the numerator and x into 4x in the denominator. I can simplify this and write it as 1 by 2. Then I have sin x by x whole square. I also have 4x by tan 4x. And I have 3 plus cos x. So what I've done here is I've rewritten the limit as the product of 4 terms, right? So the first term is a constant. As x tends to 0, the second term tends to 1. The third term also tends to 1. And the fourth term tends to 4. Right? So what is the final answer? The final answer is 2. Question 64. Limit n tends to infinity. NC3 minus NP3 by NQ. Right. So what is the shortcut to expand NC3? It is n into n minus 1 into n minus 2 by 3 into 2 into 1. Because it is NC3, you write down 3 terms in the numerator, 3 factorial in the denominator. Whereas NP3 is simply n into n minus 1 into n minus 2. Right? So now what what do we have to calculate? Limit as n tends to infinity. NC3 minus NP3. So I can take n into n minus 1 into n minus 2 common. That would leave 1 by 6 minus 1. And then I have to divide this whole term by n cube. Right? Now, how do we evaluate a limit of the form n tends to infinity, where numerator and denominator are polynomials in terms of n? We have to divide both numerator and denominator by the largest power term. So here I'll be dividing both numerator and denominator by n cube. So that will give me limit as n tends to infinity 1 into 1 minus 1 by n into 1 minus 2 by n into minus 5 by 6, right? So here I have n cube. N by n cube will give me n square. So I can write n minus 1 into n minus 2 by n square as n minus 1 by n into n minus 2 by n. So that's how I get 1 minus 1 by n into 1 minus 2 by n. Now as n tends to infinity, 1 by n tends to 0, right? Which means this term tends to 1, this term tends to 1, and you already have minus 5 by 6 here, which means the value of the limit is minus 5 by 6, right? Question 65, another question on continuity in this particular exam. So you have f of x is continuous in the interval minus 1 to 1. I would want to recap another important point here. We've dealt with some piecewise functions in this paper, right? Now in question 60, for continuity, we evaluated limit at 0 and f of 0. In question 56, we evaluated limit at 4 and f of 4. And in question 51, we calculated limit at x equals pi by 2. So what is common here? Why did we take limits at different points in these different questions? The answer is that we always look for discontinuities at points where the definition changes, right? So here from minus 1 to 0, f of x has one particular definition. From 0 to 1, f of x has another definition. The definition changes at 0. So if we want to check for continuity in this interval, if the function is continuous in the interval minus 1 to 1, then it must also be continuous at the points where the definition changes, which is at 0 in this particular case. So what does that mean? It means that f of 0 should be equal to limit as x tends to 0 minus f of x. And this should be equal to limit as x tends to 0 plus f of x, right? Now f of 0 is minus 1 by 2. According to the definition, if x is equal to 0, then I have to consider this as the definition of the function. Now for the left limit, limit as x tends to 0 minus, when x is less than 0, the definition of the function is root over 1 plus px minus root over 1 minus px divided by x. And for the right limit, you have limit as x tends to 0 plus, the definition of the function is 2x plus 1 by x minus 2. Now in either case, the function, these two values will be equal. As you can observe, the right limit is also equal to minus 1 by 2. So the necessary condition here is limit as x tends to 0, root over 1 plus px minus root over 1 minus px divided by x equals minus 1 by 2. Now on the left hand side, the limit is of the form 0 by 0. So you can use L'Hopital rule to evaluate it, although I would like to discuss an alternative also here. Using L'Hopital rule will also give you the answer. But what if you rationalize the numerator? If you rationalize the numerator, you get limit as x tends to 0. The term remaining in the numerator, once you rationalize it, will be px divided by x times root over 1 plus px plus root over 1 minus px. Right? The rationalizing factor multiplied in both numerator and denominator, and this is minus 1 by 2. So x I can cancel out. And when I apply the limit value, I will get 2c in the numerator, 2 in the denominator. This is minus 1, right? So let me just check. P by 2 equals minus 1 by 2. Yes. So the value of P should be minus 1 by 2. Question 66. The maximum area of a rectangle that can be inscribed in a circle of radius r. Right. So we also have one very interesting question from maximum here. You have a circle with a fixed radius, and we want to inscribe a rectangle in this particular circle. Right. So we're trying to inscribe a rectangle in the circle. Now, so let's say we inscribe a rectangle in the circle. The radius of the circle is fixed, right? I need to maximize the area. The area is length into breadth. But let us say I do not want to take more than one angle, right? If I take length and breadth as 2 angles, then I will have a bit of a tough time, right? What instead, if I try to find out how the circle is related to the rectangle? And one such relation is each diagonal of the rectangle is a diameter to the circle, right? So this diagonal is also a diameter to the circle, right? So that means I have, so let me just label one diagonal here. So what is the length of this diagonal? It is 2r, right? Now I will assume that this angle is theta, right? So if that is the case, then the breadth of this rectangle is 2r cos theta, and the length of this rectangle is 2r sin theta, right? In this particular case, r is a constant, so I've used only one r, right? So as the area of the rectangle changes, the value of theta will change. But because this rectangle is inscribed in a circle, its diagonal length will always be 2r. Length of the diagonal will be a constant, right? So what is the area of this rectangle now? This is 2r sin theta into 2r cos theta. So this I can write as 4r square sin theta cos theta, or I can also write it as 2r square times sine of theta, right? Sin theta cos theta is sine. And what is the maximum value of this quantity? What is the maximum value of sine 2 theta? It is 1. So the area will always be less than or equal to 2r square, right? One thing you need to check here before coming to the conclusion that the area is 2r square. When will maxima happen? Maximum happens when area is maximum when 2 theta is pi by 2. That is theta is pi by 2, which is possible in a rectangle, right? Must check for that. Check for whether that is possible before going to the conclusion. So theta equals pi by 4 is possible. In fact, when theta equals pi by 4, the rectangle is a square, right? Question 67. Foot of the perpendicular of the point 2, 0, 5 on the line is alpha, beta, gamma. Then which of the following is not correct? Right. So you have a line. Now, what information do we have about this line? There is a fixed point on this line with coordinates -1, 1, -1. And we know that a vector 2, 5, -1 is parallel to this line. Let us call this vector P bar, and let us call the fixed point A. Now the given point P is 2, 0, 5. We want to find the foot of the perpendicular, right? Let us say the foot of the perpendicular is n, right? So which of the following is not correct? You will observe one thing here in the options. If you want to answer this question, you must find all three coordinates alpha, beta, gamma, right? So first we have to find the foot of the perpendicular from P to the line. So how do we assume a general point on the line? First step we take is assuming a general point on the line. So equate this to lambda, which means x plus 1 by 2 equals lambda. So you get x equals 2 lambda minus 1. Similarly, you will get the coordinates of n is 2 lambda minus 1, comma, 5 lambda plus 1, comma, minus lambda minus 1. Now we need to write the condition for Pn to be perpendicular to the line. Because it is a foot of the perpendicular, Pn bar should be perpendicular to the line, or it should be perpendicular to the vector v bar, right? So that means Pn bar dot v bar equals 0. From here you get the value of lambda. And once you get the value of lambda, you have the coordinates, you have all three coordinates of n, which will give you the values of alpha, beta, and gamma. Right? So let's move to the next question. Let d be the distance of the point of intersection of the lines from the point. Right. So two lines are given here, and you need to find the point of intersection. Right. And solving that is not a straightforward thing as we do in 2D geometry. Here, instead, let us take a general point on the first line. So that general point will be 3 lambda minus 6, comma 2 lambda, comma lambda minus 1. Similarly, we take a general point on the second line. We'll assume another parameter here. Let us say it is mu. So you have 4 mu plus 7, 3 mu plus 9, 2 mu plus 4. Now for some value of lambda and some value of mu, both these points must coincide. Then only there will be a point of intersection. So that means for some value of lambda and mu, 3 lambda minus 6 should be equal to 4 mu plus 7. 2 lambda must be equal to 3 mu plus 9. And at the same time, lambda minus 1 equals 2 mu plus 4. Right? So you can solve any two of these three equations to get the values of lambda, to get the value of lambda or mu. But please remember that if you solve any two of these equations and that solution does not satisfy the third equation, it means that the points don't intersect. Right? Here, if the points intersect, whatever solution you get for any two of the equations will also automatically satisfy the third equation, right? So once you get either the value of lambda or the value of mu, you have the point of intersection. Question 69, let alpha, comma, beta, comma, gamma be the image of the point and R be the point. Okay, so you are given a line again. You are given a line. This line passes through 0, 3, 1. A fixed point on the line is known. A vector parallel to the line is known. The components of this vector are 1, 1, minus 1. Right? Now you have the point P. No, you have P is the image of Q. So let us say the given point is Q, 3, minus 3, 1. And P is the image of Q. Right? R is also given. Right? If the area of the triangle PQR is lambda. So how do you find the area of a triangle in 3D geometry? Right? So this area of triangle PQR. So you have a very straightforward formula in 2D geometry. In 3D geometry, you might have to use the cross product, right? So you have half modulus PQ cross PR. Or in fact, you can take the cross product of any two adjacent sides of the triangle, right? So here to find the area of the triangle, we need the coordinates of P. So let us join Q to P, which means by definition, this angle should be 90 degrees and these two distances should be equal. What does that mean? It means that the midpoint of P and Q should lie on the line. And what does it also mean? It means that N is the foot of the perpendicular from Q to the line. So in the previous question, we discussed how to find the foot of the perpendicular. So this particular question is just an extension of that. Once you find the foot of the perpendicular, you can easily find the image of that point, because if you know the foot of the perpendicular, OM bar equals OP plus OQ by 2. M is the midpoint of PQ. Once you know M and Q, you automatically have. And once you find out the coordinates of P, you can easily find half modulus PQ bar cross PR bar. All right, so let's move to the next question. Oh, another question on continuity here. So you have for a comma b greater than 0, let f of x equal. We are given three different definitions here. So once again, the change in the definition of the function happens at 0, right? So f of 0 must be equal to limit as x tends to 0 minus f of x equals limit as x tends to 0 plus f of x. Now, according to the question, f of 0 is 3, right? Because it is given that f of x is 0 when, f of x is 3 when x equals 0. Now we need to equate the limits, the left limit and the right limit. So how do you evaluate the left limit? So limit x tends to 0 minus f of x. Here you take tan of a plus 1 x plus b tan x divided by x. So this is a limit of the form 0 by 0. We can use L'Hopital rule to simplify this, right? So if you differentiate numerator and denominator separately, you get a plus 1 secant square a plus 1 x plus b secant square x. Oh, or you don't even need the L'Hopital rule. These are standard limits. These are standard limits. I can split this into two parts. I can write this as limit as x tends to 0 minus tan of a plus 1 times x divided by x plus b times limit as x tends to 0 tan x by x. As x tends to 0, you get this limit equal to a plus 1 plus b times this limit is 1. So the left limit is a plus 1 plus b. Now the right limit, again, I think you can just rationalize the numerator, right? When you're taking the right limit, you have limit as x tends to 0 plus root over ax plus b square x square minus root ax divided by b root a into x root x. Again, a limit of the form 0 by 0. Now, if you rationalize the numerator, what remains in the numerator? We get b square x square. And in the denominator, you have b root a times x root x times root over ax plus b square x square plus root over x. Right. So this is the part, this is the rationalizing factor. Now, what do you observe here? I have x square in the numerator, x root x in the denominator, but I can also factorize another x from the terms inside the square root, right? So if I do that, I will get limit as x tends to 0 plus b x square upon root a times x square. So to make this term in the denominator x square, I need to take x common from inside the square root. So that will be root over a plus b square x plus root over a. So finally, x square gets cancelled out, and the value of this limit will become b by root a into 2 root a, that is b by 2, right? So to recap, we have the left limit as a plus 1 plus b. The right limit is b by 2a, and both of these should be equal to the value of the function at 0, which is 3. So once you equate both the left limit and the right limit to 3 and solve for a and b, you will get the values of a and b, right? Or if you look at the question, they're asking for b by a. b by 2a equals 3. So you will get b by a equals 6. You don't even have to solve for b and a in this particular question, right? The right limit is b by 2a, and it should be equal to the value of the function. So b by a equals 6, right? Sometimes it just happens that you don't even have to solve for a and b. If you notice the question properly, you don't have to do a lot of solving, right? Anyway, let's move on. Question 71. Limit as x tends to infinity, step off tan inverse x, and limit as x tends to minus infinity, step off tan inverse x, right? So what is the range of tan inverse x? The range of tan inverse x is minus pi by 2 to pi by 2, right? As x tends to infinity, tan inverse x tends to pi by 2, which means step of tan inverse x will be 1. The reason for this is pi by 2 is approximately 1.57. So step of tan inverse x is 1. Similarly, as x tends to minus infinity, tan inverse x tends to minus pi by 2, which means step of tan inverse x is minus 2. Right? And the reason for this is minus pi by 2 is approximately minus 1.57. So the step value of that will be minus 2. So you get L1 plus L2 is minus 1. All right. So this, well, I hope it's not a problem because I think you're at an offline paper, but let me see what I can do about it. Right. So question 71. The answer here is minus 1. Although I'm not sure if you'll be able to mark that in your OMRs. So let's check. Do you everything correct? 1 minus 2. Yes, the correct answer is minus 1. Anyway, let's get back to that later. Question 72. If by dropping a stone in a quiet lake, a wave moves in a circle at a speed of 3.5 centimeters per second, then the rate of increase of the enclosed circular region. So the idea here is when you have a wave in a lake, right? The expansion of the wave is radially outward, correct? Let us say this is a circular wave. If it expands, the direction is radially outward, which means this speed that is being given is the rate of change of the radius. So this is 3.5 centimeter per second. And the radius is also given. The radius is 10 centimeter. You need the rate of increase of the enclosed circular region. That is dE by dt. Another hint is that they've mentioned the units also, right? So this will be d by dt of pi r square. Do not forget to use the chain rule of differentiation here. So you get 2 pi r times dr by dt. So you may have to round off the answer also here. But they've given you an approximate value of pi to be able to do that. So it is not a problem. Question 73. Modulus A equals to within the value of modulus of A cross I whole square plus modulus of A cross J whole square plus modulus of A cross K whole square. So one of the many ways to answer this question. In fact, it's actually a very useful result to remember, but we'll be discussing that solution here, not the result itself. So modulus of A cross I cap whole square is modulus of A cap whole square, modulus of I cap whole square into sine of the angle between A bar and I cap, right? Sine square of the angle between A bar and I cap. Now, what does this angle denote? Angle between A bar and I cap, let us call it alpha, right? Then the given expression will be modulus A square times 1 into sine square alpha plus sine square beta plus sine square gamma, where alpha is the angle between A bar and I cap, beta is the angle between A bar and J cap, gamma is the angle between A bar and K cap. And I've taken 1 here because we are finding magnitude of I cap square. So you remember a very familiar result. If a vector makes angles alpha, beta, gamma with the x, y, z axis, then cos square alpha plus cos square beta plus cos square gamma is 1, which means sine square alpha plus sine square beta plus sine square gamma will be 2. So the answer to this question is 2 mod a square, right? Question 74. Number of points at which the function f of x is mod 2x plus 1 minus 3 mod x plus 2 plus modulus of x square plus x minus 2 is not differentiable. So I would suggest to be very cautious about questions like this because we have to check for differentiability at points where the definition of the function changes. And because we have three modulus functions here, that will happen at three different points. So when does the definition of modulus of 2x plus 1 change? That happens at x equals minus 1 by 2. The definition of modulus of x plus 2 will change at x equals minus 2. And the modulus of x square plus x minus 2 will change its definition when x equals 1 or minus 2, right? The first modulus becomes 0 at minus 1 by 2. That is where it changes its definition. Second modulus becomes 0 when x is minus 2. The third modulus becomes 0 at two different points, but those are 1 and minus 2. So this means that you have to write down the definition of the function based on these values, right? So what we'll be doing is first we write down the points where the definition changes. These are minus 1 by 2, minus 2, and 1. Now we divide the domain of the function into different intervals based on these three values. So I can say f of x will have one definition for x less than minus 2, another definition from minus 2 to minus 1 by 2, another definition from minus 2 to 1, another definition for x greater than or equal to, right? Because the definition changes at minus 2, minus 1 by 2, and 1, you have to break the domain into these intervals. There are 3 points, so there'll be 4 intervals. Now, when x less than minus 2, 2x plus 1 is negative. So f of x will be minus of 2x plus 1 plus 3 times x plus 2 plus x square plus x minus 2, right? The reason here is modulus x is minus x if x is negative and plus x if x is positive, right? So when x is less than minus 2, f of x is minus of 2x plus 1 plus 3 times x plus 2 plus x squared plus x minus 2. So let me write that down here. Let me simplify this further. So this will be x squared plus 2x x minus 1 minus 2 plus 3, right? So x squared plus 2x plus 3 when x is less than minus 2. Now let's take the case where minus 2 less than or equal to x less than minus 1 by 2. So here 2x plus 1 is still negative, so its modulus is minus of 2x plus 1. X plus 2 is positive, so I can write minus 3 times x plus 2. X squared plus x minus 2 is negative, so here I have to write minus of x squared plus x minus 2, right? So this will become minus x squared minus 6x minus 1 minus 6 plus 2. That's minus 5. This is the definition for f of x at in the interval minus 2 to minus 1 by 2. Now, when x lies between minus 1 by 2 to 1, then 2x plus 1 is positive, so its modulus can be written as 2x plus 1. X plus 2 is positive, so its modulus is the same as x plus 2. And x squared plus x minus 2 is negative, so it still remains minus of x squared plus x minus 2. So this, when simplified, becomes minus x squared minus 2x, 3 minus 6, so minus 3, right? And finally, when x is greater than or equal to 1, all the terms involved are positive. So I'll get f of x is 2x plus 1 minus 3 times x plus 2 plus, was it plus here? Yes, plus x squared plus x minus 2. This is x squared, x squared plus 1 minus 6 minus 2. So x squared minus 7, right? Now, for differentiability, first we check for continuity. So at minus 2, what is the left limit? F of minus 2 minus is 4 minus 4 plus 3, that is 3. F of minus 2 plus is minus 4 plus 12 minus 5, which is also 3. Right? So the function is continuous at minus 2. Now we have to check for differentiability. So f dash of minus 2 minus is 2x plus 2 at x equals minus 2. So this is nothing but minus 2. And f dash of minus 2 plus is minus 2x minus 6 at x equals minus 2. This is also minus 2. Right? So you observe that the left derivative and the right derivative are both the same, which means the function is differentiable at minus 2. Right? Although the definition changes at minus 2, the function is differentiable at minus 2. And similarly, we have to check for continuity and differentiability at minus 1 by 2 and also at 1. Right? So this particular question is one of the lengthier ones in this paper. But please do remember, just because the definition of the function changes does not mean that the function will be non-differentiable. You have to check at each of these points. Right? So I hope you'll do the same with x equals minus 1 by 2 and x equals 1. Question 75, 4 points are given. Projection of line segment AB on CD. So what is the projection of AB on CD? It is AB bar dot CD bar by modulus CD bar whole modulus. Right? You're trying to find the length of the projection. So it is, you take a modulus after finding this one. Right? And because A, B, C, D are given, you can easily find B bar and C. So that concludes our discussion of this paper. Thank you very much.